All right, section 9.6, remind yourself that 9.6 is the one where we translate all of the conics. In this case, we're going to translate hyperbolas. So, thus far, everything has been centered around your origin. Now we're going to take these hyperbolas and we're going to shift them around just like we did with parabolas and ellipses. So maybe these branches are going to be here and here or something like that. Okay, so no longer will the center be at the origin. So you're going to be translating. Things get a little more challenging, of course, when we translate. So here's the equations you'll want to jot down, and I'm just going to remind you that we already talked about these equations in the previous video. So x squared minus y squared tells you that it's going to be stretched in the horizontal direction, right? So you're going to have a horizontal hyperbola. If y squared comes first and then it's minus x squared, it's going to be stretched in the y direction, hence you're going to have a vertical axis parabola. A squared is always first on a hyperbola, b squared must equal 1, and now we just have the whole h and k concept, and I think you're very familiar with the fact that hk is your center. Asymptotes get trickier now because your hyperbolas won't be centered at the origin, so your asymptotes won't have a y-intercept of 0 anymore, so I'm going to focus on that because that's probably the trickier part of all of this. Remind yourself important characteristics still are center, foci, vertices, and asymptotes. Okay, so hopefully you jotted those down from the previous section. So here we go. I'm going to start out with graphing the equation of this translated hyperbola. It's all set up and ready to go. It's the difference. It equals 1. Y squared comes first, so I might just remind myself because y squared comes first that it's going to be a vertical. It's going to be stretched in the vertical direction. I know a squared is 16 and b squared is 4, so a is going to be 4 and b will be 2. And again, I just square rooted 16 and square rooted 4. That's probably obvious. My center is going to be hk, and be careful because y comes first. It's easy to just kind of go from here to here. So h is actually positive 1. And k is negative 2. Remember, they're always opposite signs. So my center is positive 1, negative 2. And actually, I'm going to start there before I go any further. So 1, negative 2 is the center of my graph. And I'm going to just put an X through that, as I always kind of do with my center. And I'll stop there. So then I know in the y direction, I'm going to go 4 units. So from my center, I'm going to go up 4 and down 4, and those will be my vertices. Okay, and I'm going to list those. Actually, I can probably graph that without blowing it up too much. So in the y direction, I'm going to go 4 units above and 4 units below, and those are my vertices. Now, if I hadn't graphed these, I can see that my vertices are going to be 4 units plus or minus my y value, right? So my vertices are going to be 1, comma, negative 2 plus 4, which is 2, and I can see that point right there, and negative 2 minus 4, which is negative 6, and I can see that point also. So 1, 2, and 1, negative 6 are my vertices. And let's see, other things, foci, important characteristics, right? So foci, even though it didn't ask you for that, I'm just going to go through it anyhow. So foci is, I'll use c squared equals a squared plus b squared. And you can figure that out. That math is easy. So a squared plus b squared, 16 plus 4 is 20. So c squared equals 20. Square root 20, and I know that c is going to be plus or minus 2 root 5, square root of 20, and that's reduced. So again, square root of 20 is like 4.5-ish. So I know that my foci, and I'll use a different color for my foci, but my foci are going to be 4.5-ish above and below my center. So very close actually to my vertices because those are 4 units away. So those are my foci. And I'm going to write those points. My foci are 2 root 5 in the y direction. So again, from my center, my y coordinate, I'm going to add and subtract 2 root 5. And you can actually, since it's square root format, you can just write -2 plus or minus 2 root 5 and certainly leave it like that. Unless you want to separate them into 2, that's fine. So last but not least, in the x direction, I know I'm going to go b units from my center. So I'm going to plot that. So I'm going to go 2 units in the x direction from my center. Okay, so 2 units in the x direction from my center. And that's going to make kind of that rectangular box region again. That's optional. You don't have to draw it in. But that helps you get your asymptotes. So remember, your asymptotes go from the center to the corner of each of my boxes. So if I draw in my asymptotes as best as I can there we go. And then I can draw in my hyperbola branches. So I know how wide, oops, and then I totally missed my vertice. I know how wide or narrow they are. I kind of missed that vertice again. Not doing that. That foci point just tricked me. All right, so here is, again, my hyperbola branches riding along those asymptotes. And now we're going to talk about how in the world you find those asymptotes. Well, at first, I want you to note that both asymptotes go through the center, right? Your center's at 1, -2. Okay, and then it has a rise. This asymptote has a rise of 1, 2, 3, 4 over 1, 2. So 4 over 2, of course, is 2. So I know my slope is going to be plus or minus 2, and of course I know it's plus or minus because if I rise 1, 2, 3, 4 and go to the left 2, that's going to be -2. However, my y-intercepts are not at the origin anymore, so one of two things you can really count here. If I go up to over 1, this one actually does go through the origin. This one, if I go down 1, 2 to the left 1, it's going to cut through -4. If you can see this from the picture, I am totally fine with you just writing those equations for those black lines there, those asymptotes, totally fine. Okay, what I'm going to do is worst case scenario, I'm going to walk through how to find these asymptotes algebraically. Okay, so please pause the video if you don't understand and rewind where the slope came from. Okay. So I'm going to kind of go back to the equation. Remind yourself also that slope is always the a over the b, because a is underneath y in this case. So the change in y over change in x. So it's going to be plus or minus 4 over 2, and that's how I got this slope also. Okay, and so I'm going to write down here. Then I know my slope, and this is for my asymptotes. Okay, I know my slope is plus or minus 2, and I know my center is 1, -2. So I have a point, I have a slope, and good old point slope form. And again, this is worst case scenario. Like if you couldn't figure out what the equation was from your graph, maybe it's too sloppy or it's not going through exact points, then you got to use good old point slope form. So y minus the y coordinate, which is really plus 2, right, equals my slope, and I'm going to start out with positive 2, times x minus my x coordinate, which is 1, and I'm going to simplify this, so y plus 2 equals 2x minus 2, and I'll subtract 2, and I get 4. Now, I knew that from just looking at my graph, but again, this is if you want to do the algebra. Okay, now I'm going to do this again, except for I'm going to change my slope to a -2. So this would be -2 plus 2, and my other asymptote, squeeze it in here, is going to be -2x if I subtract 2 plus 0. Not that you need that, right? So my other asymptote is -2x. Okay, so again, that's the algebra that you could do, and again, you can see that the asymptotes, again, the equations of those black lines, right? You can see what they are from your graph. So it's kind of up to you how you want to algebraically find them, always possible, or maybe just from your graph. All right, last one, I'm going to go through this one a little more quickly. So graph it. All right, we know our center is HK, and x comes first, so it's going to be -3, 1. And x comes first, so I know this is going to be a horizontal hyperbola. I know it's a hyperbola because it's subtraction. Both x and y are squared, and it equals 1. So I also know that a is 9. I'm sorry, a squared is 9, so a is going to be 3. B squared is 25, so b will be 5. C squared then, remind yourself, a squared plus b squared, so that's going to be 9 plus 25, which is 34. So C is going to be plus or minus the square root of 34, and there are no perfect squares in 34. So, all right, all the stuff we can pick out mathematically. So my center is at negative 3, 1. I'm actually going to draw that first. So center is at negative 3, 1. Okay, my vertices are going to be 3 units in the x direction from my center. Okay, 3 units in the x direction from the center. So right here and here are my vertices. My foci are going to be square root of 34 units in the x direction from my center, and square root of 34 is almost 6, right? Almost 6. And I'll use a different color for that. So my foci are almost 6 units from my center. So I'll draw in those foci. And last but not least, I know from my center in the y direction I should go 5 units. So I'm going to go 5 units from the in the y direction from my center. So 5, 1, 5. And then that kind of makes that rectangular box for me. Okay, so I can draw in my asymptotes from going through my center from corner to corner on my box. Corner to corner going through the center of my box. There are my asymptotes, and then I can draw in my branches. So they have to very wide hyperbola branches, right, going through my vertices. I can see my asymptotes. Probably can count this out. Again, this is from my center to the corner of one of those boxes. I rise 1, 2, 3, 4, 5, and I run 1, 2, 3. So 5 over 3 or 5 over negative 3. So I can see that my slope is plus or minus 5/3. I can probably, well, I can see my y-intercept also actually. So if I go up 5 over 3, I can see that that y-intercept for the positive one is at 1, 2, 3, 4, 5, 6. And if I go, for my negative one, if I go down 1, 2, 3, 4, 5, and over 3, I can see that it's crossing at negative 4. So right away, actually, I know my asymptotes here are going to be y equals positive 5/3 x, and the positive one crosses at 6, and negative 5/3 x, and the negative slope asymptote crosses at negative 4. So to me, it's a lot of times real easy to pick that out from your graph. Now again, if you don't, I won't walk through the algebra again because I know you can handle it, but you can take the change in y over change in x, so that's going to be 5/3. You know that's your slope plus or minus. Use point slope form with your center because they always go through your center, and that slope, work them out algebraically, and you should be able to get that. Your vertices, you might be asked to list those. So again, from my center, my vertices are going to be 3 units from my center in the x direction. So I'm going to add 3 and subtract 3. So my vertices are at 0, 1, and negative 6, 1, and I can see that from my graph. Foci are going to be the square root of 34 units from the center in my x direction. So I'm just going to write negative 3 plus or minus root 34, comma 1. And that's all your important characteristics.